supposed to get snow, but not a lot.
I don't want no more snow.
I just want 2 hour delay, I think. According to the Farmer's Almanac,
All right. That's about the weather. This is something that you've been doing for years, and we even talked about it last semester. So let's just make sure we know what we're talking about here. If I ask you to determine the slope and the y-intercept and graph this function, that you could do that, right? That's what some kids in calculus said today. So we're starting pretty easy here today, kids.
I came to the realization I'm actually a lefty over later grade. Because, I mean, nobody can write this bad with their right hand without possibly being a lefty. So.
We just switched.
That's going to make it even worse for us.
When I was little, I used, like, usually they can say you can tell which hand you're going to write with, because when you're a little kid, you eat with that hand, you pick up toys with that hand, you do stuff with that hand. And I always did that with my left hand, and my grandma didn't want me to be left-handed, so she always switched it to my right hand. And so I'm right-handed because she forced me to be right-handed, and so I always blame my poor handwriting on my grandma not wanting me to be left-handed. Because she's crazy. It's not good. Remember that slope-intercept form is y equals mx plus b. If it's in that form, you should very easily be able to tell me the slope and the y-intercept, and you should be able to graph that, yes? Because the slope is the number that's in front of x, so I could say that the slope is 2. The y-intercept is a number by itself. And when you graph this, which one do you graph first, the slope or the y-intercept? Yeah, the y-intercept is where it crosses the graph on the y-axis, which would be 1, 2, 3. And your slope is the rate of change. How fast is that changing? And it's always a fraction. So if my slope is 2, what is 2 as a fraction? So that's my rise and my run, right? So I can rise 2, run 1. Rise 2, run 1. That's not so bad after 3 weeks of school. Not a bad place to stop. You're gonna graph a few. You're gonna have to graph much worse things than this in this class, so you better just suck it up and accept it. Look, I thought I was gonna have. If we had a 2-hour delay, look, I had planned to print these out for you, but we don't have a 2-hour delay, so I didn't print them for you. So now you have to write.
Why would we even
We're going to be done so early, you don't even understand. Because I thought it was a 20-minute discussion on weather.
Hey, do you like that shirt?
That's okay. I never showed my husband that, but I'll be showing. It's funny. Average rate of change is just another word for slope. So when they talk about the average rate of change, just know that they're asking you for the slope. So on a test, if I ask you for the average rate of change, I will not tell you, hey, I mean slope. You have to know that. But hopefully you know that slope is the rate of change of your graph, so that will be something that will be easy to do. Linear functions have a blank average rate of change. Do you think what word goes in there? You got to guess? Constant, because their rate of change stays the same. If the slope is 7, the slope is always 7, so it's always changing at a rate of 7 over 1. So I printed those out. I was going to print those out, so you just had to write the word constant. I was prepared for last week. For all you kids that leave early, because remember 2-hour delays, I don't see you kids that leave early. I was even going to write these out and print them off for you, so you can just have it and do your homework. Yeah, so that like if you came to me and get your homework before you leave, which is what you're supposed to do on 2-hour delay days, then you could have them. Like it's like just so you know, if we do ever have a 2-hour delay, if you leave early, then I won't see you, and it is your responsibility to come and get your homework. And if you don't do that, I don't have to give you I can give you a 0 the next day for not coming and seeing me. So it's just be aware of that. If you leave early and you don't see me on 2-hour delay days, you are required to come and see me. It's in the handbook. Check it out. Just saying. So the average rate of change of this y equals mx plus b is always going to be what? M, it's just a slope. So if it's in slope-intercept form, you know what the slope is. What do you think about that? Well, this class is getting you ready for calculus, because average rate of change, we use that word.
No, we're not getting ready.
Just saying. That big f of x minus h minus f of x all over h, remember that? That's getting ready for calculus. This book's all about getting ready for calculus. Alright, can I go? I'm going. Alright, let's have been better if I printed this out, huh? So part of your homework today are going to give you some XY charts. You don't really have to write the whole chart if you don't want to. You could just write the first 4 things. I made this many boxes and I didn't know how to delete it, so then I just had to fill it all in. But they're going to give you these problems and say, determine whether the function is linear or nonlinear. If linear, find the slope. So the big thing is that linear functions have a constant rate of change, where the slope should always be the same. And if they give you an XY chart like this, can you figure out what the rate of change is, or figure out what the slope is between each number? How'd you do that? Yeah, we just want to see, is it changing by the same amount? On the x-axis, or the x values, do you agree that they're each changing by 1 every time? So what we want to do, since these are all changing by 1, is see how these are changing. So what is the rate of change between 13 and 10? Minus 3, right? It's going down by 3. So I could say the rate of change between these two is negative 3. If it's linear, all we're looking for is it the same every time. So you just kind of want to check. Between 10 and 7, is that going down by 3? Between 7 and 4? 4 and 1? Yep. 1 and negative 2? Yep. So that is your rate of change. If it's linear, those numbers should all be the same. So I can say, without doing much work, that this is linear. And if it's linear, find the slope. Guess what? Your slope is that average rate of change. So your slope is negative 3. You could actually take each point and do rise over run, but you don't really have to do it on that. With me on that? That's not so bad. No, I don't think we're doing vectors right now. I don't think so. Not in this chapter. I don't know. I haven't got that far. I don't really work that far ahead. I really had a big plan. I was gonna do the whole rest of what we have to do over Christmas break, and then I didn't even take my book home. So you know. No. Oh, why is that offensive? It's funny. No, you can say yeah, it's not offensive unless you complain a lot. It's supposed to be funny. I don't know.
You actually drink
I haven't, but I might someday. Just for show.
But you didn't drink caffeine.
I know, right? I did drink a Diet Coke over break though.
Yeah. No, you drank
And I drank coffee one day when my child didn't sleep. And my child's not sleeping again, so who knows? I thought about drinking coffee this morning.
You had 3 weeks to sleep.
No, I didn't. We were up before 7 o'clock every day, and he's still not sleeping through the night. So getting up today was really no big deal for me because I don't sleep anyway. Again, all we're doing on this, as long as the x's are going up by 1s, we're just checking to see what's happening from here. So from 1 to 7, plus 6. From 7 to negative 2. If those two are not the same, can it be linear? No. So if you see that it's not the same at all, it's not linear. If you get two of the same, you got to check that they're all the same because they could trick you a little bit. So this is, they say non-linear. Not linear is probably what I would say, but non-linear works. Alright, we've talked about increasing, decreasing, and constant overall for many things, many functions. But today we're just going to look at increasing and decreasing and constant for linear functions, which makes it a whole lot easier. Because if your function is increasing, decreasing, or constant, and if your rate of change never changes in a linear function, then you can just tell by looking at the slope. Like, you don't even have to graph it. I know. Sorry to have so much work today, Ken. Were you talking to him or texting? That's just his voice that you use for him. All right. So if you have a line where the slope is positive, what does that line look like? Yeah, if the slope is positive, it's always going to be going up. So if your slope is positive, you're going to know that your graph is increasing always. You don't even have to graph it. And if your slope is negative, what kind of line does that look like? Yeah, it's going down over time, which means that if your slope is negative, then it will always be decreasing. And what kind of line has a slope of 0? Like this, which means that it will be constant. Now this only works for linear functions because linear functions are the only ones that have slope, the only ones that have a constant rate of change. All the other ones, they can change from increasing to decreasing. But this is a really easy way to find this. So I think I have one or two more examples here where on your homework, your favorite stuff, where they have you do like multiple things on one problem, right? Let's do one of those. And we're almost done. And you're going to have so much time, you're going to get your homework all done this year. Oh, no, wait, we're going to do this one first. So we could just say this, but it's all right if you want to write it down. I'll be quiet for a minute. And then we'll do one together. I think how much faster we would have been done with printed out notes. We would have been done like 10 minutes ago. You would have had 45 minutes. Determine if each function is increasing, decreasing, or constant. You don't have to graph it. All you have to know is look at the slope, right? So what do you think about number 4? Increasing, decreasing, constant. The slope is negative, so we can say it's decreasing. What about number 5? The slope is positive, so we say increasing. And what about number 6? If there is no slope, there's no x in that, so that means it's a 0 slope. So we say constant. Pretty much on your homework, everything we've done so far, you're going to do in like one problem on a few of these. Like you're going to graph it, you're going to say the slope and the y-intercept. You're going to say whether it's increasing, decreasing, or constant. I don't know, maybe something else. Let's see if I got one more. Oh my gosh, I don't even have one more. I only have 7 problems on your homework. Ridiculous. I don't like it though. Grades are done, buddy. I'm not doing anything else. It's in your review. I gave you points for your review, like walking around. Remember? Number 30 at the end asks you to solve a few things, so try that before you just ask me how to do it. You should be able to do that as well, just solving some equations. But other than that, it was pretty easy. You have like 20 minutes, so get this done, and you don't have to worry about homework tomorrow. I mean, tonight. Well,